Welcome to mechanical engineering students. In mechanical measurements, we are going to discuss today sine bar, its construction, its working principle. So what is sine bar? Sine bar is used for measuring an unknown angle, of the workpiece by using a trigonometric relation sine theta is equal to h by L. Since it is using the trigonometric relations and the sine principles, it is called as sine bar. It is also used for locating the workpiece to the given angle. So in this case, we are finding the angle of this workpiece. What is this angle? That we are finding with the help of sine bar. It is also possible to locate any workpiece to the predefined angle. That is also possible. So in the sine bar, you have these two cylinders. These are called as rollers. And the center to center distance between these two rollers is known as length between the centers, and it is denoted by capital L. And these are slip gauges, which are ring one after the other. So this is known as the height of the slip gauge combinations. Then the workpiece along with the sine bar, roller and the slip gauges are placed on this surface plate. Surface plate is to be used for conducting the experiment by using the sine bar. Then what is the construction of the sine bar? Sine bar has got these two rollers, and the entire instrument is made up of high carbon, high chromium, corrosion resistant steel. These two cylinders of equal diameters is attached at the end. As we have said, the length between the two centers is denoted by L, and it is known as length of the sine bar. There are these end faces. You can see the end faces, then upper surface and lower surface. To the end, you have got these rollers. The distance between these two rollers varies, and for a given sine bar, it is constant. This distance can be 10 inches, 20 inches, or 100 mm, 200 mm, or even 300 mm. You can also see these small holes here. These small holes, they are called relief holes. They are called as relief holes because they are there to reduce the weight of the sine bar and to facilitate the easy handling of the sine bar. So these are the relief holes, are nothing but the drilled holes. These holes are drilled here. So once you drill the hole, the weight automatically comes down. So this is regarding the construction of the sine bar. How it is used? As we have said, it makes use of the sine principles to calculate the angle. This is the angle which we want to measure. This is the angle we are interested in measuring. This is sine theta. Theta. Then if you make use of the trigonometric principle, sine theta is equal to this opposite side divided by this hypotenuse. What is this hypotenuse? Length of the centers. This hypotenuse is length of the centers. So sine theta is equal to h divided by this L. You can measure this h by the slip gauge combinations. H can be measured with the help of this slip gauge combination. Then L is fixed. What is L? It is the length of the sine bar. So the slip gauges are used because they are the master standards of measurement, and the entire combination, sine bar, workpiece given, slip gauge combination, is placed on the surface plate. Okay, so the theta can be calculated by the equation sine inverse h by L. Then we can also check the unknown angle by this method also. Here we have got, apart from the slip gauge, sine bar, workpiece, we have got the dial indicator. Let us see how it works. We can use this for checking of unknown angles. Initially, measure the angle of this workpiece approximately with the help of a bevel protractor. Make use of the bevel protractor and measure the angle approximately. Once you know the angle, you can get the height of these slip gauges. How much height I can use, you will come to know this. Length of the sine bar is fixed, that you will be knowing it. So height is sine theta into length. It will give you the height of the slip gauges to be rung. After this, we can set the sine bar at that angle. What is that angle? Theta, as it is obtained by the bevel protractor. And then it is kept and clamped to the angle plate. The sine bar is clamped and workpiece is also clamped here to the angle plate. Then you can move the dial indicator from one end of this workpiece to the other end of the workpiece. Once you move this dial indicator, what happens is, if the dial indicator is showing deflection, then still we have to make adjustments in the slip gauges. We have to make the height of the slip gauges in such a way that the dial indicator here shows zero deflection. So the slip gauges here are adjusted in such a manner that the dial indicator, when it is moved from this end to this end, it shows zero deflection. Once it shows zero deflection, you measure this height of the slip gauges, then divide this by the length of the sine bar. Once you get that answer, you can calculate the angle theta. So this is the way to check the unknown angles. Then we can also conduct the experiment like this. Here there is dial indicator. The length between the centers is shown as L. The sine bar is placed like this. The lower end of the rollers is placed on height of slip gauges. You can call it as H2. And the upper end of the rollers is again placed on the some combination of height of slip gauges. You can call this as height H1. Everything is placed on surface plate. So in this case, sine theta is the difference between these two heights, H1 and H2, that is H1 minus H2. Divide this by the length of the sine bar. Okay, then you can get the angle sine theta. So similarly, you have to arrange the dial indicator here to show zero deflection when it is moved from this end to this end. Once it shows zero deflection, you have to adjust this slip gauge combination. You adjust the slip gauge heights in such a way that the dial indicator, when it is moved from this end to this end, shows zero deflection, as it is explained in the previous case. So this is the method to find the unknown angle sine theta. Once you get sine theta, you can find theta as sine inverse of this whatever answer you get. So to conclude, the sine bars are used to calculate the angle of the workpiece, that is this angle of the workpiece. Then it can also be used to set the workpiece to the given angle. So how to do that? To set the workpiece to the given angle, height should be known, height into length. So again, you have to make use of this equation. This angle is known to you, this height is not known. So sine theta into this length will give you the height. So it is possible to do both the things here. You can set the angle as well as you can set the height, because length is fixed here. So this is regarding the sine bar and how to do the experiment using the sine bar.